All right, 9.1, 9.4 quiz review. Let's get after it. So the very first one says, name each regular polygon. Regular means that you have equal sides and equal angles. So this one has 5 sides, 1, 2, 3, 4, 5. So that is called a pentagon. Pentagon is 5 sides. Find the value of x and y, and then find the sum of all the interior angles. Well, we might want to start right here. The sum of all the inside angles. That means how much are all 5 of these added together. Like we know that triangles are 180. But we have a formula for this. It's the number of sides take away 2 times 180. So this particular shape had 5 sides. So 5 take away 2, which is 3. And then you multiply it by 180 degrees. So this one would be 540 degrees total. So anytime a shape has 5 sides, all the angles add up to 540. If it's regular, you can then divide that by 5 and split it up evenly. So if you divide that number by 5, you'll find out that every angle inside is 108 degrees. And that'll let you find the exterior angle. Why? Because if this angle right here is 108, and these two angles, the inside and the outside, form a straight line, they have to add up to 180 degrees. So 180 minus the 108 means y is 72, x is 108, the sum was 540. All right, this next one, this is an octagon because it has 8 sides. So to get the total inside here, if I do 8 minus 2 times 180, that's 6 times 180, which means there's 1,080 degrees inside of an octagon. And now to find each corner, each vertice separately, you just divide that number by 8 to divvy it up equally. And all of these should be 135. So my interior angle x is 135. So to get the outside angle, they form a straight line, subtract from 180, y should be 45. So there are my 4 answers. I named it. I got the sum, the inside, the outside. All right. For any polygon, the sum of the outside angles is always, so there's no formula for this. There's just a fact. It always adds up to 360 degrees, the outside of every shape. What's the difference between regular and irregular? I already kind of told you that, but regular means equal sides and equal angles. All right, that's regular. So if we scroll on down and we look at number 5 and number 6, these are not regular. These are irregular because the angles aren't all the same. So the question is, how much is this corner worth? Well, first of all, I count the sides. 1, 2, 3, 4. So how many are supposed to be, what's the total if you have 4 sides? Well, 4 minus 2 times 180. That's 360 degrees. So every shape is 360 degrees. So what I'm going to do now is I'm going to add up how much I have. So I go 87, 111, 59, and add that up. 17, carry the 1, that's 9, 10, 5, carry the 1. 257 is what I have so far. So we subtract from 360. It looks like I need 103 more degrees, and that will give me the full 360. This one over here has 5 sides. So when I do 5 minus 2 times 180, I get 540. So let's add up what we have so far. 106, 101, 90, 90. That gives me a grand total of 387. So how much am I missing? And I can see it's a pretty big angle. It's going to be way more than 90. 540 minus that, that's going to be, 140 plus 13, 153. Correct answer for this one. Keep on going. Find the missing values for a parallelogram. So we need to know our properties of a parallelogram. So one thing, our opposite sides are the same length. So if this is 12, that means this side's 12. If this side is 8, that means this side is 8. Now, as far as angles go, in a parallelogram, opposite corners have to match each other. So if we have a 69 up there, we have a 69 down here. And again, since opposite corners have to match, this corner has to match that corner. And I can either add those two up, 69 and 69, subtract from 360, and then divide it by 2. But there's also a property that says in a parallelogram, or anything where there's two parallel lines and then this line coming through, these angles have to add up to 180. This angle and this angle has to add up to 180. So I'm just going to do 180 minus 69. I think that comes out to be 111. So you're 111, you're 111. You could double check it. We should now have 360 degrees and opposite corners should be equal to each other. Number 8 gets into the diagonals and what the diagonals do. So there's lots of things going on here. From back earlier in the chapter, we know that vertical angles inside here, maybe I'll start in the middle, have to be the same. So 122 and 122. I know that these two angles form a straight line, 180. So if I subtract 180 minus 122, I'll get 58, and I'll get 58. And now we can jump inside some triangles. You know, if I focus on triangles up here, let's look at this red triangle up at the top. Well, I have 2 out of the 3 angles. I have 122 and I have 41. So that's 163. Triangles only have 180 in them. So when I subtract that, it looks like you have to be 17. And there's always going to be some symmetry between that top triangle and this bottom triangle. There's other ways to get this, but there's going to be some symmetry here. It's not quite a reflection, but it rotates around. And this kind of goes back to chapter 3. But when you have parallel lines like here and here, and they form this Z, these angles in this Z have to be equal to each other. So this is my 41. This would be my 17. Notice that this piece over here equals that piece down there. And then we have the same thing going on with these other 2 triangles. If this is 96, up here has got to be 96. And then we will add the 96 and the 58 up for this triangle, and then subtract that from 180. So those 2 add up to 154, subtract from 180. I believe leaves me with 26 degrees in those 2 corners. So you kind of have some congruent triangles there that are rotated around. All right, another thing about the diagonals of a parallelogram are they bisect each other. Meaning, like, I have a small diagonal, maybe I'll do it in blue, small diagonal, and then I have a big diagonal, a long one. But they cut each other through each other's midpoints. So this point right here is the midpoint for both of those, meaning that this piece equals this piece, and this one equals this one. So let's see what they ask here. They say if BE is 7, well, that tells me that ED is 7. And then they give me some algebra. They said AE from A to E is 5x plus 1. And then E to C is 2x plus 10. Well, I know those 2 are equal to each other, so I'm going to set up some algebra and set them equal to each other. And I minus from both sides. Subtract 2x, subtract 2x. I get 3x, so I've moved all my x's to the left. So I need to move my constants, or my numbers, all to the right. And then solve it, divide by 3, divide by 3. Whoa. And I get x equals 3. So solve for x. We just did that. And then we need to find the length of ED, which was 7. Now, if I want to find the true length of AE, I need to take this 3 and I need to substitute it in. And that's 5 times 3 plus 1. That's 15 plus 1. So you're 16. And since they have to be equal, I could substitute this also over into here, or I could just trust my work and know that they have to be the same. All right, moving right along. Number 10, use a square to find some missing values. So one thing we know about a square is that every corner is 90 degrees. And we also know that when you come down and you drop a diagonal, it breaks that 90 degrees perfectly in half. So 45, 45, all the way around. These are all 45 degrees, all the way around. And we also know that the diagonals in the center there, they cross at 90-degree angles. Plus, you also know that 45 and 45 is 90. So to make a triangle, but all squares do this little pattern of 45s and 90s. Now, the last little hard part was we're trying to find out how long this side is. You know, so if we just focus on, you know, this triangle right here. Well, if I want to find out how long that green line is, I can do the Pythagorean theorem, because one leg is 5 and this leg is 5. So I have a 5 and I have a 5 and a 90 degrees. And I'm looking for this hypotenuse. So I can use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 25 and 25 is 50. And then to get x all by itself, to solve this, I take the square root of both sides. And I find out that that side length is about 7.07. So there's a little bit of Pythagorean theorem going on there. Now a rhombus is a special shape. It's basically a parallelogram with 4 equal sides. So it's just like every other parallelogram, but it's got 4 equal sides. And it also crosses like a square where it's got 90 degrees in here. So all those corners are 90. So if this is 90 and that's 31, that means to get 180, this is going to have to be 59. And now the cool thing about a rhombus is that triangle flips all the way around. It's just the same triangle that just keeps reflecting all the way around. Those diagonals bisect the corners. They split everything in half. So that's kind of a cool thing about a rhombus. Number 12, use the rectangle to fill in all the missing angles. Well, a rectangle is kind of like a square in the fact that every corner equals 90. So that's pretty important. But the diagonals don't split it in half. It's not a 45-45 situation. So if the whole thing is 90 and this little piece right here is 27, if I subtract those two, I find out that here's 63. And whatever happens there has to happen up top because these things are symmetrical. You know, this piece equals this piece. They're all equal. The diagonals bisect each other. But in a rectangle, they're the exact same length. You don't have a short one and a long one. So I now, since this is really an isosceles triangle, 2 equal sides means I have 2 equal angles. Well, to get the third angle, let's add that up. We have 63 and 63. That's 126. And subtract from 180 gives me 54. So I've locked that triangle down. That's going to open up the door because this triangle right here should match this one over here. It's a reflection of itself. So I can just copy these over. And even that 34 side right here is going to be a 34. So we know that rectangles have equal sides. The lengths and the widths have to match up. Well, now let's get after this bottom one. This bottom one, if I have 27 on this side, I have 27 on that side. And I could either add those up and subtract from 180, or I could play the straight line game. 180 minus 54 is, what's that, 126? And now we can just reflect the bottom triangle up top. And we have everybody. So the key thing to know is there are 2 sets of congruent triangles that reflect on each other for a rectangle. All right, trapezoid. So what is a trapezoid? Well, a trapezoid basically has 2 parallel sides. That's it. So all we know is that this side is parallel to that side. So there's not a lot of cool symmetry going on here. I can't flip and rotate and move things around. But because those lines are parallel, similar to early on, I do know that this angle and this angle have to add up to 180. That always has to happen between parallel lines. So 180 minus 109 is 71, I believe. So that'll add up to 180. This side over here also has to add up to 180. So if you're 50, that means you are 130. So I got my angles locked down. Then we have this thing in here called the median. This line X right here, the middle line, the midline. It's called the median. You might want to think of it as the midline because it's exactly in the middle of these two numbers. So if I want to know, what's exactly in the middle of between 43 and 85, well, you can average them. You can add those two numbers up and then divide it by 2. So that would be what, 128 chopped in half? Looks like that line is 64. So the median would be 64. And in general, the top is called base number 1. The bottom is called base number 2. And what we did was we did base 1 plus base 2 chopped in half. That's a formula that will always find the median for you. All right, now we get into our good friend the kite. Kite is kind of a wannabe rhombus, but it doesn't have 4 equal sides, so it's kind of like a rhombus. It's like a rhombus in the fact that it does cross at 90s in here, and that'll help me get some triangle stuff going on. So 90 plus 72, take away from 180, I'm going to get an 18 here, which on a kite, you can fold that over so that this triangle and this triangle match each other. And then the triangle over here on the left, or on the right, 90 and 43, subtract that from 180, you'll get a 47, which that has to match this triangle. So this triangle and this triangle match each other. And you can kind of play a symmetry game. A kite, you can fold it, along this line right here. That's a fold line that you can flip everything and it should match, land on itself. And then we have to get a few different pieces. The big piece now that we have left is we need to know what x is. Well, because we have this 90-degree angle, this is really a right triangle. So if I kind of come over here and redraw it, it's a right triangle, which opens up the Pythagorean Theorem door. And this is 8, and this is 26. And that's the hypotenuse. So leg squared plus leg squared equals, I don't know, squared. Let's crank this out. I'm going to use a calculator here. 8 squared plus 26 squared is a big number, 740. Now I take the square root of both sides, and the square root of 740, about 27.2. That's how long this side right here is. That was a little bit tougher. Number 15's got a star beside it. Solve for x and y. So we do have a trapezoid. I see that this top base, this B1 up here is 14. They don't give me the bottom base. They don't give me the B2. But what they want is they want me to figure out how far that little y part is. And then they want me to figure out, how far x is. So they basically want 2 parts of a right triangle. Well, what I can do is if this is 10, I can slide that across, and that means that this line is also 10. All right. Well, now there's a couple things we can do. We can do special right triangles, or I'm going to take you down the trig route, because we know that this is 60, we know that this is 90, and we know that this is 10. So we got to get some pieces. Let's go after x first. Well, if I go after x, I'm going to put my guy on 60. I label my sides. 10 would be the opposite. This is from chapter 8, the trig chapter. This would be hypotenuse. Well, opposite and hypotenuse, sine is opposite over hypotenuse. So the sine when standing on 60 degrees is the opposite over the hypotenuse. Well, now I have to solve it. I put a 1 under it, cross multiply. Cross multiply. I don't know what x is, so to get x all by itself, I got to do the opposite of times by sine of 60. So I divide, and let's just do 10 divided by the sine of 60. And I'm getting 11.54, 11.5-ish. So 11.55, I guess, if I round it. And then I could redo the same game for y. I could either use Pythagorean Theorem, since now I have two sides, or if I want to get y, I just kind of erase that, and I put a y here. And now when I label it, I have opposite and I have adjacent, which is tangent. So the tangent of 60 degrees is opposite over adjacent. Play the same game. But now I'm going to divide both sides by the tangent of 60. So 10 divided by tan 60. Boom. Looks like 5.77. So that one was a little bit tougher. That's why I had a star beside it. A little bit rougher. Last one, find the length and slope of all four sides. So the length is just, well, let's do the slope first. So this line is increasing. It's going up from left to right. So I know it's going to have a positive slope. And how I find the slope is it's rise over run. Rise over run. So it looks like 4 over 1. So I know that that line has a slope of, so the slope is 4 over 1. And if I want to find out how long that side is, I can just do the Pythagorean Theorem, because I have leg, and then hypotenuse. So leg squared plus leg squared equals, I don't know, squared. So that's 17. We don't really need the number. Let's just say it's the square root of 17. So I have the length and I have the slope. Now, if this is going to be some sort of parallelogram or rectangle or something, I need to have parallel sides. Well, this line over here also has a slope of 4 over 1. And when you do the Pythagorean Theorem, it's also the square root of 17. So right now, I have one pair of parallel sides. All right? Well, if I do the other two, if I look at that and I look at this, those slopes are negative. Okay, they're dropping. So that line is actually dropping 1 and running 1, 2, 3, 4, 5. So that has a 1:5 ratio, a 1 to 5. So a negative 1/5 for slope. A negative 1/5 for slope. And if I want to find the length of it, I do 1 squared plus 5 squared equals, I don't know. So that's 26 is x squared. Like I said, I don't really need the number. I'm just trying to see if the two sides are equal. And they are. They're both the square root of 26. So right now, let's write down what we have over here. You know, I now have two pair of parallel sides. So that right there tells me we have a parallelogram. That's the definition of a parallelogram, is we have both sides parallel. You know, we have the blues are parallel to each other, which that would be just a trapezoid. But now we have the other ones too. So now we've locked into, we could either be a parallelogram, we could be a rectangle, we could be a rhombus, or we could be a square. Well, I know that I'm not a square because I didn't have 4 equal sides. You know, this side and this side are different lengths. So I can't be a square or rhombus because these two, all 4 sides are equal. I didn't have that. Now, do I have a rectangle? Well, it looks like a rectangle, but the big question is this 90 degrees? And if two angles are 90 degrees, their slopes have to do something special. The slopes have to be opposite reciprocals of each other, or opposite flips, we said back in chapter 3. And they're not, because the blue one was 4 over 1. The red one was negative 1 over 5. So they are opposites. You know, I have a positive and a negative. But they're not flips of each other. They're close. 4 over 1, the other one's 1 over 5. If that had been 1 over 4, we'd have been in good shape and we could have called this a rectangle. But it's not a rectangle because it's not 90 degrees. So we're stuck at parallelogram. All right, hopefully that helps you out. Get you ready for the quiz or the test. See you.